Hey, what's up guys? This video is the spring final review for year 2022. It is part 1. I'll probably make 4 videos. If I can, I'll make 3 just to make it shorter. But make sure you guys review and look at each question so you guys are ready and prepared for the final. So let's start with question number 1. In question number 1, it says, what is the solution to the graph? They give you guys linear functions, so you guys have 2 lines crossing each other. This point right here is where the 2 lines intersect, and that is where is the solutions for the graph that you guys have. Now the 2 lines right here, since they are crossing, we call this a system of equations because we have 2 different lines, 2 linear equations, and we want to know what are the x value and the y value for the solution. So this point right there, we need to know the coordinate of the point. So that's going to be from the origin, the x value 1, 2, 3 to the right, and 2 steps up. So my solution will be 3, 2 for this system of equation. Now keep in mind that we do have an x value and a y value when you guys are looking for that solution. So 3, 2 is the answer. Number 2, it says solve the system. Now this is again a system of equations because you guys have 2 linear equations. We have one on top, one on the bottom. Notice the x value has an exponent of 1. That is why it's a linear equation. And we are looking for the value of x and the value of y. Now there's a couple ways you guys can solve the system. One of them is the substitution method. The second is the elimination method. Now if you guys go back and look at the y values, I noticed that they have almost close to the same coefficient. So this is a 2, this is a 1. So I'm thinking of using the elimination method where I can eliminate the y, solve for x, and then I can solve for the y value. Now to use the elimination method, we need the same coefficient, same number, and opposite signs. So I need to change this y somehow so I can have the same number as the top y and the opposite sign. So all we have to do is multiply the bottom equation by a -2. That is how you're going to get the same number for the y and opposite sign. For the x, they're not going to have the same number sometimes. Sometimes they will, but we just have to know what's going to happen to the x. But right now my goal is to cancel the y. So I'm going to multiply the bottom. The top equation is going to stay the same. So I'm just going to rewrite the top equation, 4x plus 2y equals 14. In the bottom, you guys distribute the 2. So we have a -2 times 8x. That's going to be a -16x. The -2 times the y. That is a -2y. And if you guys pay attention to the y's, now they have the same number and opposite signs, and that's how we're going to eliminate the y's. But I also have to multiply the -2 times the -25, and that is a -50. So I'm going to put a line under the system. So here's a line so I can start adding or combining like terms. So I look at the x's. The x's don't cancel. So I'm going to combine 4 minus 16, 4x minus 16x. That's going to be -12x. The y's cancel. So that's my goal. I wanted to cancel the y's. That's why it's called the elimination method. I eliminated the y's. And the other side, you guys are going to have -36. So now you guys can get the x by itself. So I am going to divide by -12 both sides, and that's I'm going to solve for x. So x equals, we will have a positive because we have 2 negatives. Negative divided by negative will be +3. So that's the x value. But now we need to find the y value. So I'm going to go back to one of the original equations, doesn't matter which one, and I'm going to substitute this x value into the x. This one or this one, doesn't matter which equation. I'm going to choose the top. Anyone can choose the bottom, doesn't matter, we will get the same answer, but you guys are going to substitute. So the top equation will be 4x plus 2y equals 14, and I'm going to substitute the 3 into the x. So I will have 4 times 3 plus 2y equals 14. So 4 times 3, that's 12. And you guys are going to solve for y. Subtract 12 from both sides. So I'm going to get positive 2y equals positive 2 on the other side. Divide by 2. And y equals positive 1. So my answer has to be in a as a point. So you guys have an order pair. So you're going to have parentheses like this. You always have the x value first and then the y. It is alphabetical order. X is before the y. So x is 3 and the y is 1. So my solution will be 3, 1. So I'm going to put here solution. It's always an order pair when you guys have a system of equations. And one more time, the x is always first and then the y. Number 3, it says solve using the elimination method. Now they do tell us what method to use. So I am noticed that if you guys look at the y's, they have opposite sign and they have the same number. They have an invisible 1. So by using the elimination method, we can start eliminating the y's. It's already set up for us to eliminate the y's. So that's good. So we don't have to multiply anything. So I'm just going to put a line under the system. I'm going to eliminate the y's like this. I'm going to combine the x's. 1x plus 4x. They're both positive, so you're adding. That's going to be 5x. 12 plus 33. That's going to be 45. Then you guys divide by 5 on both sides. And you guys solve for x. So x equals 45 divided by 5 is 9. So we got that answer for x. Then you guys go back and you substitute into 1x. Doesn't matter which one. I like the top because I don't like big numbers. I see that 33. I'm going to try to avoid it. So I'm going to go over here and I'm going to substitute into the x. So the top equation, I'm going to put here substitute. And we have x minus y equals 12. And you guys substitute that 9 into the x. So it's going to be 9 minus y equals 12. And you guys solve for y. So you guys subtract 9. Negative y equals positive 3. We have to get rid of that negative. So you guys are going to divide by negative 1. And y equals negative 3. So my answer, my solution will be an order pair. Remember, x is always first and then the y. So x is 9 and the y is negative 3. So here's my solution. It is an order pair. Number 4 says solve using the elimination method. And again, we do have a system of equations. Since they say elimination method, I am looking at the x values now. Those x values have the same number and opposite sign. One's a negative, the bottom is a negative, and the top is a positive. So you guys can cancel the x's. 2x minus 2x is 0. So I'm going to start with the x, eliminate the x right here. I'm going to combine the y's. So we have a 5y minus a 1y. That's going to be 4y equals, and the other side, 6 minus 6 is 0. I am going to divide by 4. Divide and divide. So y equals 0 divided by 4 is 0. Now guys, very important. This is the value of y. Y is a number. It is 0. We know the value of 0 is nothing, but it is an answer. Do not say this is a no solution system, because that's wrong. It has a solution, but the y value is just 0. So you guys need to go back and substitute the y, the 0 into the y. Doesn't matter which equation, you can use the bottom or the top, and you solve for x. I'm going to use the top equation. So I'm going to put a substitute here. We have 2x plus 5y equals 6. You substitute the 0 into the y. So we have 2x plus 5 times 0 equals 6. And you guys solve for x. So 2x plus 5 times 0 is 0 equals 6. I don't need that 0 because 0 is nothing. So 2x plus 0 is just 2x equals 6. You guys divide by 2 and we get an answer of x equals 3. 6 divided by 2 is 3. So my solution, one more time, it is an ordered pair. The x value is first, that's 3, and the y value is 0. So notice that we do have a solution. We have 1 point. The ordered pair 3, 0 is the solution for this system of equations. Question number 5, it says solve the system of equations by substitution. Now here they're asking for a different method, the substitution method. The substitution method is when you guys substitute one equation into the other equation. So there's 3 steps that you guys can follow. Step number 1, you always want an equation with a variable by itself. Now here, we're lucky because we have 2 equations with the y by itself. So it doesn't matter which one, but you guys need to use one of them for step number 1. You're going to use one equation with the y by itself. I am going to use the top equation. I'm just going to rewrite it. Y equals negative 3x plus 11. And that equation, I'm going to go to step number 2. I am going to substitute into the other equation. Now the other equation, which is the bottom, the one I didn't use in step number 1, is y equals 6x minus 34. So I'm going to take all the y value, y equals negative 3x plus 11, all of this into the y of the other equation right there, because all of this is the value of y. So I'm going to substitute into that variable. So I'm going to have negative 3x plus 11. I'm going to bring down the equal sign. So I have an equal right here. You bring it down. Equals, and then you guys bring down 6x minus 34. Notice that we have the same variable in this equation. So we are able to solve for x. Now we do have x's on both sides. So I'm going to get the x on one side and the constants on the other side of the equation. So you always do the opposite of the smallest x. Negative 3x, it is smaller than positive 6x. So I am going to do the opposite of negative 3. You add 3 to both sides. So you're solving for x. Negative 3 plus 3 cancels. We have a positive 11 equals 9x. 6 plus 3x is 9x minus 34. Now you guys can get x by itself. So you add 34 from both sides. And we get on the left side 45 equals 9x. And you guys cancel the 34. Finally, you guys divide by 9 to get x by itself. So 45 divided by 9 is 5 equals x. Okay, so we know what is the value of x. So step 3, you guys are going to substitute that value of x, which is 5, into one x value. Doesn't matter which one. You guys just need to use one equation from the original system. I'm going to use the top, but like I said, it doesn't matter which one you use. Anyone can use the bottom and we will get the same answer. But the top equation is y equals negative 3x plus 11. And I'm going to substitute the 5 into the x. So we have y equals negative 3 times 5 plus 11. So you guys simplify. Negative 3 times 5, that's negative 15 plus 11. So y equals negative 4. So that's the y value. So my solution, it is an ordered pair. And we have the x value first, which is 5. And the y value second, which is negative 4. So my solution for the system, 5, negative 4. Number 6, now it's a little bit different. It says, which of the following equation matches the standard form of a quadratic? Now you guys have to remember what is a quadratic and what is the standard form. First of all, quadratic is when you guys have an x squared. You guys have a degree of 2. The standard form of a quadratic is f of x equals a times x squared plus bx plus your c. Remember that f of x can be the same thing as y. So each one of these equations, they do have a y. So we don't have to worry about the f of x. But notice that the standard form, first of all, it doesn't have parentheses. It has an x squared. And you guys have 3 values, a, b, and c. Sometimes you are missing one of those values. But it's very important that you guys see we don't have parentheses and we do have a degree of 2. So I'm looking at this equation, the first one top on the left side. That one doesn't have an x squared, so I know that is not a quadratic, so you cross that one out. This one, it has a degree of 2, but it has a parenthesis. So this one is not in standard form. This one here is actually in vertex form. We didn't talk about that in class, but it is not standard, so we are going to cross that out. Now if you guys look at this one, well, we do have the x squared, the 5x, and the c. No parentheses, and we do have a square. So this one here, it is the standard form for a quadratic. If you guys want to check the last one, well, the x doesn't have a square. So that's not a quadratic. This is actually a linear equation, but we're not looking for linear. We are looking for a quadratic. So you guys cross that one out. So the quadratic standard form is y equals x squared plus 5x plus 6. Number 7 says find the zeros of the equation. Now this word zeros is another name for solutions. You guys can also say x-intercepts, or you guys can say answers. So we have solutions here, and that's what we're looking for. We're looking for the answers of x. So even though it says the word zeros, remember that is the same thing as the answers. You're looking for the value of x. Notice that we do have parentheses, x plus 4 times x minus 7 equal to 0. This is not in standard form, but it is a quadratic, because if you multiply, we're not going to do that, but if you multiply x times x, that's going to be an x squared. So it is a quadratic equation, but the good news is that it's already set up to use the zero product property. So the zero product property is when you have those factors, parentheses already, you guys are going to equal those to 0. So I'm going to do that right now. X plus 4 equals to 0. And then you guys take the second one, x minus 7 equal to 0. And you guys solve for x. So the first one, you guys subtract 4 from both sides. So x equals negative 4. And the second one, you add 7 to both sides. So x equals positive 7. So we have two answers, and they're both x values. It's not an x and a y. We don't have a y. We solve for the zeros, for the x-intercepts. So you guys have two answers, x equals negative 4, comma, positive 7. If you guys think about the parabola, the u-shape, the graph of a quadratic equation, well, the graph is going to cross the x-axis at these 2 points, at the x equals negative 4 and the x equals positive 7. So we found the zeros of the equation. Number 8, it says find the axis of symmetry. So we are looking for axis, which is a vertical line that cuts the parabola in half. And I'm saying parabola because it is a quadratic function. You guys have an x squared. We have f of x equals x squared plus 6x plus 11. So it is a quadratic, it is a u-shape, the graph, a parabola, and we're looking for the axis of symmetry. To find the axis of symmetry, we have a formula, which is the same thing as the x for the vertex, but the formula is x equals negative b over 2a. That's it. You guys are going to substitute the a and the b. So I'm going to look for those values. A in this function is 1, and that's the one next to the x squared. We have an invisible 1. B is negative 6, the one with the x, right here, the x term. And you guys can say the last one is c, but we're not going to use it right now. I'm going to put it here so you know the constant is the c value. But we only need to use the a and the b. You're going to substitute into that formula. So we have x equals negative b, which is negative 6, over 2 times a, which is 1. So x equals positive, the top, negative times negative will be positive 6 over 2. So x equals 3. That's it. You guys found the axis of symmetry. It is at x equals 3. And again, guys, this is the same thing as the x from the vertex, because the axis of symmetry will cross the vertex in every single parabola. But we found the equation x equals 3 for the axis of symmetry. Number 9, what is the axis of symmetry? They're asking the same question. We do have a quadratic function. We have a y instead of f of x, but they're the same thing. But we know it's a quadratic because the highest exponent is 2. So we do have a formula to find the axis of symmetry. X equals negative b over 2a. So I'm going to look for my a value. This one, a is 2. That is the one with the x squared right there. B is negative 8, which is the one in the middle, or the x term, that one with the x. And C, the constant, is 11. We don't need C again, but it's a very good idea to know what is C. So I'm going to substitute. So in that formula, negative B, which is negative 8, over 2 times A, which is 2. You guys are going to simplify. So the top, negative times negative, that will be a positive 8. And the bottom, 2 times 2 is 4. You guys divide. A divided by 4 is 2. So the axis of symmetry is at x equals 2. Number 10, it says factor, and we have a quadratic trinomial. Quadratic because degree is 2, highest exponent is a square, and we have 3 terms, 1, 2, and 3. So it is a quadratic trinomial. Factoring is when you guys are looking for the factors, the parentheses, the binomials, or anything that will multiply to get that trinomial back. So I show you guys a method, and the method I use is the X diagram. So I'm going to use the X right here. I will multiply the A times the C. So remember that the A is the one with the variable squared. So right now it is an invisible 1. So A is 1 in this trinomial. And C is the constant, the one at the end, the number with no variable. So I'm going to multiply A times C, and I'm going to put it on top of the X. So 1 times 12 is 12. B is the one with the K, or the variable with a degree of 1. So we have a positive 7. So I'm going to put that on the bottom of the X right here. Now I need to find 2 factors that will multiply to 12, and they add up to positive 7. And this is where you guys have to try it. You guys have to look for those factors. If the first one doesn't work, don't give up. Try it the second time or the third time. Just make sure that you guys find those factors. So in this case, I am thinking of 3 and 4. Notice, 3 times 4, 12 when you multiply, and 3 plus 4, 7. So this works. When the X diagram works, it means you can factor. Yes, you can. So the next step, you guys are going to write your 2 parentheses, which are the binomials. You're going to bring down the A value. So you guys have to go back and look at the A. So A is 1. You're going to put the 1. I will write down the 1 inside the parentheses. And you split up the K squared to a K times a K. So this is what it's going to look like. You guys bring down the 1, K, and 1K inside the parentheses. Then you guys bring down the factors. So this one, positive 3, it is positive. You always have to check your signs. So plus 3 here, positive 4 goes over here, plus 4. You always have to check if you guys can divide the binomials, but when A is 1, you're not going to be able to divide because the numbers, the only thing they have in common is 1, and you don't have to divide by 1. So when the A value is 1, you don't have to worry about dividing the binomials, and that's the answer. Now we don't need that 1 next to the K, so let me just rewrite. Without the 1, we have a K plus 3 times a K plus 4. So those are my factors. If we multiply, if you guys distribute these 2 binomials, we will get this trinomial back. That's the idea. When you guys factor, you guys are looking for what multiplies to equal to the trinomial that we have at the beginning. Another thing, guys, the order doesn't matter. So when you guys look at your answers, you might have the K plus 4 on the left side and the K plus 3 on the right side. It doesn't matter because when you multiply, we do have a property, the community property multiplication. It says order doesn't matter when you guys multiply. So as long as you guys have the correct numbers and the correct signs, you guys will be okay. So this concludes the first video for the final review, spring final review for year 2022. I'm going to make a couple more, maybe a few more videos. Make sure you guys check those out. Always practice, get ready for the final, and I'll see you guys later.